Welcome to Time Doesn't Pause, the podcast where we talk about the future. My name is Al Kumbis, and today we're discussing the pros and cons of editing the human genome and taking control of our own evolution. Human embryo editing seems like something out of a science fiction novel, but like self-driving cars and artificial intelligence, these far future technologies are being used today, proving that we are well and truly in the future. And now that we are in the future, the question is no longer can we genetically modify humans, but should we? If this technology develops and becomes commercially available, will we experience a Gattaca-esque dystopia where genetic material is used as a class system and anyone without top-notch genetics is oppressed? Or will we experience a beautiful Tomorrowland utopia where artificially intelligent robots don't plot the destruction of mankind and everyone lives longer, happier, healthier lives? Fortunately, we're a long way off the dystopian path. There are thousands of ethics committees around the world whose job it is to regulate the way science is performed and the kinds of science we're allowed to perform. For example, animal ethics committees are attached to major scientific research organizations or universities to make sure all animals used for scientific purposes are completely essential for the study and humanely treated. Because this kind of research is relatively new, there are no major ethics committee rulings that regulate human embryonic gene editing, which means we need to create global agreements between countries and scientists about what we can and cannot do when it comes to editing a human embryo. Research of this nature is currently limited by government regulations. For example, the National Institute of Health in the United States doesn't provide public funding to projects that aim to edit the human genome, but these studies could still be privately funded. Previously, this kind of research was incredibly difficult, as we didn't have the technology that was precise enough to genetically modify a human embryo without causing major problems. However, now we have a nifty, cost-effective new way to modify DNA that is orders of magnitude more precise than previous methods, and scientists around the world are itching to try it. It's important to remember that genetic modification isn't new, the slowest form being evolution. Before we even knew what DNA was, we created a way to speed evolution up by selective breeding. Just look at the hundreds of varieties of dog breeds that exist today, or go to your local supermarket and see all the varieties of fruits and vegetables that are available to you. These are just two examples of ways we've manipulated DNA to do what we want. And nowadays we can do a lot more than even that. Between making glow-in-the-dark rabbits and cloning sheep, scientists have been busy for the last couple of decades learning as much about DNA as possible. And that's where CRISPR comes in. Not only does it take genetic modification into the future, it's also a great system to use for genetic research. The acronym CRISPR stands for Clustered Regularly Interspaced Short Palindromic Repeats, which translated into English means a strand of DNA with a repetitive sequence. Cas9 is a nuclease, which is an enzyme that cuts DNA. Together, the system accurately targets and cuts DNA, which allows scientists to either add in new genes, change existing genes, or delete genes. But what would we use this for? The versatility of the CRISPR-Cas9 system means that, quite possibly, we will only be limited by how fast we can discover new genes. Soon, the limits of human imagination will be the only thing holding us back. The major ethical concerns surrounding this technology have been debated at international summits of scientists, as labs around the world begin to look into researching human modification. If we eventually decide to use these technologies outside of the laboratory, it will have a huge impact on us all, as our genetic modifications will be passed on to future generations. There are three ways this technology could be harnessed in the future. First, health and medicine. Developmental disabilities, congenital risk of cancer, and genetic disorders could be the first targets of CRISPR technology. However, there are many reasons why people might not want to use genetic modification, such as culture, personal belief, or cost. Will we be creating a next-generation cure for all ailments or an ableist society that further discriminates against differently abled people? Second, the military. Imagine super soldiers with increased muscle mass and an impossibly high pain threshold. An army of Captain Americas might seem like a cool idea for a comic book, but in real life, what are the implications? Genetically created super soldiers would have to have their lives chosen for them upon creation. Would their parents decide this, or the government? And third, commercial use. Capitalism will take this technology and do what it does best: sell. Companies will offer body and aesthetic modifications, from changing your hair and eye color to growing an extra limb or even a tail. Unfortunately, the human race has a dark history of using new technology to find fun new ways to oppress minorities and create wealth inequality, and human embryo editing technologies, if used for the wrong reasons, could quickly get out of hand. However, if used morally and ethically, our new future could be pretty great. Thanks for traveling through the future of evolution with me. Once again, I'm Alcumbus, and you're listening to Time Doesn't Pause.